All right, welcome class to Unit 6, Notes 2 on exponential growth. So go ahead, I want you to pause the video here and write down all this information into the top square rectangle box on your 6-2 notes. And then when you come back, we'll chat about them. All right, hopefully you paused it there. If you didn't, pause now. So if we look here, this looks very similar to what we looked at on 6.1 equations. The only different thing here is that we have 1 plus r in there. And in 6.1, I already gave you what was happening in the parentheses. C is our initial amount, the amount we start with. R is rate of change, but not as a percent. So remember, if it gives it to you as a percent, we're going to move the decimal point 2 to the left. T is in time. And then also, we're not adding or subtracting anything in these examples, so C is value is also our y-intercept. So let's go ahead here. I'm going to write off to the side before I fill in where it says equation. 8, and then in parentheses, we're going to be thinking 1 plus my r value, which was not a percentage. And so here's my work. I need to simplify and add those two to make this my equation. So now I can write in my equation y equals 8, and then in parentheses 1.45 to the t. Just like in all of the examples that we did in 6.1, we started at -1 and we went up to +3. So to go ahead and find these values, we 6.1 notes, we would type them in, but then we learned, hey, I can just go right to my y equals on my graphing calculator and type this information in. So let me pull up my graphing calculator quick for you. All right, so here I have my graphing calculator. If you go into your y equals, and now you're going to want to type in our function 8 parenthesis 1.45 close parenthesis, and then our exponent is going to just be x, and so we have that variable there. And now we can go to our table to find our values. So second graph will bring us to our table. Now I want my table to start at -1, so I'm just going to arrow to -1. If your numbers are way different than this, you can go ahead and sit second window. And here you can change where your table starts, and you can also change what its increment is at if it's not at 1. So I'm going to go back. Now these are my values that I'm going to want to plug in to my table. So I'm going to jump back to my smartboard lesson for you, and I get 5.52, 8, 11.6, 16.82, and 24.39. Those just came right from my graphing calculator. So then I go ahead and graph these. -1, I'm up at 5.52. 0, I'm up at 8. 1, I'm at 11.6. 16.8, so almost to 17. And then 24 is going to be off my graph, so I don't really need to graph that. All right. So very much so like what we did in our 6.1 notes. So let's go ahead and look at our next example. Here, my r is 1/3. So in my equation, I have my c. Now I have 1 plus 1/3. So 1 and 1/3 to my t. So I'm going to go ahead, same numbers in my x and y, or my x values. Now when you type this into your y equals, I'm just going to go ahead and hit clear. I have 6. Now in my parentheses, I don't want to change it to 1.3. 1.3, 0.3 repeating is 1/3. I'm going to write this as 1 plus, and then 1 divided by 3. So that's 1 plus 1/3. So that's 1 and 1/3 to the x. This will give me my answers that I want. If I put it in as 1.3, it's going to give me close, but as my exponential increases, it is going to get further and farther away from what the truth would be. All right, so go ahead and jump back to your table and fill those values in. 4.5, 6, 8, 10.6 repeating, and 14.2. Go ahead and graph those for me. So we are doing growth, so all of our graphs are going to have that same picture. All right, so two graphs replicated a lot of what we saw in 6.1. So let's go ahead and look at some word problems then. In 1971, there were 294,105 females in high school sports. Since then, the number has increased to an average of 8.5% per year. So it says write an equation to represent this. So the first thing we need to identify is our C value. That's our starting value. And then our rate. And now our rate is given to us as 8.5%. We don't want a percentage, so we are going to move the decimal point 2 points to the left. So 0.085 is our rate, not as a percentage. So my equation, y equals 294,105. Now remember, in the parentheses, we take 1 plus my rate, so that will give me 1.085 to the t. And there's our equation. And then it says, according to that equation, how many females participated in sports in 2020? So 2020 is the year, and this is talking about since 1971. So we need to take 2020 and subtract 1971 from it. And that gives us 49. This is our t value. So you're going to go ahead and take our example, or I mean our equation, and you're going to plug in 49 in for your t. So this is not going back to the table. You're just going to type this right into your calculator, 294,105 times 1.085 to the 49th. So if I jump to my calculator here, I'm going to do this on my home screen. So 294,105 parenthesis 1.085 and then exponent of 49. So this is how you're going to go ahead and type it into your calculator. So I want you to do that and then get an answer for me. So how many females participated in high school sports? 16,203.52. And we're just going to leave it as that decimal because some people would round it up, some people would round it down. We're just going to leave it. All right. So in 2010, the city of Rushford had a population of 1731 and a growth rate of 2.1%. 1731 is our C value. 2.1% is our R value, but it's a percentage, so we're going to move that decimal 2 to the left, 0.021 for our R. Go ahead and I want you to pause here and try and write yourself the equation without me having done it. All right, hopefully you got that done. So y equals 1731, 1.021 to the t. Okay, so then it says, what's the approximate population in 2023 and 2030? So we're starting in 2010, and to go to 2023, that is when our t is 13. And 2030 is when our t is 20. So go ahead, pause the video here, and plug 13 into your equation, and then plug 20 into your equation and get the two answers. All right, so hopefully you did that. And we get 2,261.94 and 2,623.08. All right, so then that brings us to compound interest. So this has got a lot of stuff to write down. Pause the video here and write these things down into your big open box next to compound interest. All right, hopefully you guys got that down. This is similar to our compound, or I mean, our exponential growth. The only different really thing is that we have this r plus, divided by n and n times t there, and we'll look at that. Again, interest rate, our R needs to be given to us not as a percentage. And then the other thing to think about is T is the number of years. So if it tells you 6 months, you're going to put 0.5 in because 6 months, 0.5 is half of a year. Okay, so then it says talks about number of times compounded per year, and then you have this little on the side. Daily is 365 times, weekly is 52 times, monthly is 12, quarterly is 4, semi-annually is 2, and annually is 1. So this is just how many times, how often they calculate the interest on your amount. All right, so Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will be there in 10 years? So let's go ahead and find our P, our principal, our initial value, which was 14,000. My rate, they said 6%, but we want it not as a not as a percentage. So you would have this percent, our decimal, ooh, and you'd move it 2 spots over, so 0.06. And my N, how often is it compounded? It says compounded monthly. So N is 12, and T is how many years? So 10 years. Okay, so now I'm just going to go ahead and plug it into my formula. So 14,000, 1 plus my rate, 0.06, divided by my N, how many times it's compounded. And then in my exponent, it's going to be N times T. All right, so let's go ahead and jump to our calculator and see how we can type that in. So some of you feel confident in being able to type it in all in one step, and that's just great. You just want to make sure you're watching your parentheses. Now, some of you have a calculator that will pop things into those nice fractions for you. If you don't, you're going to have to just put extra sets of parentheses in. So you could type it in all in one step. 14,000 parentheses 1 plus, now I'm going to throw another parentheses, 0.06 divided by 12, close parentheses, close parentheses. So I need 2, 1 to close off the division and 1 to close off the addition. And now in my exponent, and if yours doesn't pop it up into that exponent, you're going to need to throw a set of parentheses there also to make sure your 12 is getting times by your 10. Mine puts it up into the parentheses for me. All right, then go ahead and hit enter, and we see that there's $25,471, and then we're dealing with money, so 55 cents in the account. All right, go ahead and I want you to pause it and try plugging this in for yourself. Determine the amount of an investment of $300 invested at an interest rate of 3.5%, compounded semi-annually for 22 years. So go ahead, pause the video, and try and write this into the equation on your own. All right, how did you do plugging it in? Good. If you have an error, go ahead and tweak it. If not, then call it good. And then I want you to pause it and put it into your calculator now. All right, hopefully you did that. So we end up with $643.63 after 22 years. All right, there we have it for notes, ladies and gentlemen.